Hello, welcome back. Today we're going to be talking about interpreting x and y axis intercepts. The objective is that by the end of this video, you should be able to find and interpret the meanings of the x and y axis intercepts in an equation that models a given situation. A hot air balloon is 1,500 feet in the air. It is descending toward the ground at 300 feet per minute. The situation can be modeled by the equation h equals 1,500 minus 300t, where h is the height of the balloon and t is the number of minutes the balloon has descended. As we work through this problem, we're going to do the following. We're going to define our variables, we're going to find the intercepts of the function and then graph the function using those intercepts. We're going to tell what each intercept represents. That's interpreting the intercepts. Then we're going to identify the function's domain and range and tell what the domain and range mean in the situation. Let's take a look at those first two set of instructions: defining the variables, finding the intercepts, and graphing the function. Defining variables. In this case, the variables were actually defined for us. H is the height of the balloon, and t is the number of minutes the balloon has descended. So I'm going to define the variables as h is the height, and t is the number of minutes. Now what we're going to do is we're going to actually take the equation and we're going to find the intercepts and then graph the function. Let's go ahead and find the intercepts first. Now I know it's in h and t and we're used to working through the problem using x and y. That's okay, finding the intercepts still has the same basic process. H in this case is going to be like y and t is going to be x, since you notice y is written, or sorry, rather h is written as a function of t. Let's find our t-intercept first. To find the t-intercept, notice the t is in the x spot. It's going to be some number, comma, 0. Because we're going to put 0 in for the other letter than t. So to find the t-intercept, we take our function, h equals 1,500 minus 300t, and we put 0 in for the other letter than t. We put 0 in for h. So 0 equals 1,500 minus 300t. We then solve for t, minus 1,500 minus 1,500, and we get negative 1,500 equals negative 300t. We can solve for t by dividing both sides by negative 300. And that gives us t is equal to negative 1,500 over negative 300, which is a positive 5. So our t-intercept is a positive 5. So now that we found the t-intercept, or like the x-intercept, now we can find the y-intercept, or in this case, the h-intercept. So to find the h-intercept, we put 0 in for the other letter. Now, the other letter is t, so we're going to put 0 in for t. So we take our equation that we were given, and just like when we found the t-intercept, to find the h-intercept, we put 0 in for the opposite letter. So h is equal to 1,500 minus 300 times 0. 300 times 0 is just 0, so h is equal to 1,500. So when t is 0, by the way, the ordered pair is t, comma, h in this case. When t is 0, h is 1,500. Now that we have our intercepts, we can draw the graph of the function. So, to draw the graph of the function, we notice that our two intercepts in this situation are both positive. And since we're talking about a hot air balloon and its height, we know that both the time and the height will both be positive. So it's going to label our axes. Since h is a function of t, that means our h acts like our y, so The y-axis will be our height, or h. The x-axis is going to be our time in minutes, or just t. Now our height, the hot air balloon started at 0, 1500. So I'm going to put 1500 right here. That's our starting point. Now the balloon's going to descend. Descending means the balloon's going to go down. After 5 minutes, where is the balloon? At 5 minutes, by the way, time, we need to label our axis, telling you what unit we use, time in minutes, height in feet. So after 5 minutes, the balloon reaches a height of 0 feet. So we can connect our two dots with a line, and this allows us to graph the function. The third set of instructions we were asked, or we were given, were to tell what each intercept represents. Well, the t-intercept, when the time is 5 minutes, the height is 0 feet. So the t-intercept is when what? So here we're looking at the t-intercept. When time is 5 minutes, the height is 0. What's going on with the balloon? The balloon started at 1500 feet and went down towards the ground. It descended. So the t-intercept is when the balloon reached or hit the ground. So when the balloon landed. What does the h-intercept stand for? Notice the h-intercept is 0, 1500 feet. So the h-intercept represents when the balloon started up in the air. So in this case, it's where the balloon started. Our last set of instructions ask us to find the function's domain and range, and then to write the meaning of the domain and range. Let's find the domain first. Now, we're not talking about x and y, we're talking about t in minutes and h in feet. So our domain is on the x-axis, or in this case is t. Notice, all of our time values start at 0 and get bigger all the way to 5. That means our time is between 0 and 5 minutes. Our range, notice the balloon starts at 1500 feet and goes all the way down until it lands on the ground, which is 0 feet. So our range is between 0 and 1500. To write down what each one of these means, the domain represents the time and the range represents the height of the balloon. Here's another problem situation for you to work through on your own. Please read the problem situation, then read the instructions, and see if you can't follow each one of the 5 instructions that you're given. We didn't define the variables for you since they were defined in the problem situation. We were told that y is the amount of air, and notice I say it's in psi, pounds per square inch, and x is the number of days since the air has started leaking, so x is number of days. Now we're going to find the x and the y-axis intercepts and then graph the function, and we're going to tell which each one of the intercepts represents. So I'm going to go ahead and write the function right here below, giving us y equals 40 minus 2x, and we're going to need to find the x-intercept and the y-intercept. To find the x-intercept, we put 0 in for y, giving us 0 equals 40 minus 2x. So again, the x-intercept, we put 0 in for y and solve for x. Subtract 40 from both sides, and we get negative 2x is equal to negative 40. Divide both sides by negative 2, and we get x is equal to a positive 20. Let's find the y-intercept. To find the y-intercept, similar situation, you put 0 in for x and you solve for y. This one's a lot easier because when we put 0 in for x, we notice that we're left with just 40 for y. Let's go ahead and graph the function. Now we're talking about air pressure and time, and since we'll never go back in time in this situation, we can go ahead and make our axes all positive. The x-axis is going to be the time in days. The y-axis is going to be the psi, or the amount of air. So our tire started off at 0.40, or 40 pounds per square inch. The amount of air in the tire then went down from there all the way until x was 20. So after 20 days, the tire pressure was 0. So we can go ahead and connect those two dots with a straight line. And this is 0, 0. And we're going to interpret the two intercepts. As I was talking through the problem, I interpreted for you 0.40 represents when the tire started off. So the y-intercept in this case situation is the starting tire pressure. Now, what does the x-intercept represent? The x-intercept is when the tire had lost all of its air, so the number of days until there was no air. The next set of instructions is going to ask us to find the domain and range and interpret the meaning of the domain and the range. Since we already have the graph, I'm going to go ahead and erase everything except for the graph. And let's find the domain and range of this function. Now the domain. Notice all of your x values go between 0 and 20. So your number of days, which is your domain, goes from the first day all the way until 20 days when you had no air left in the tire. The range, which is the tire pressure, goes from, again, 0 to 40, and the y values are between there. Notice when we write the domain and range, we always go from least to greatest. So even though the tire pressure started off 40 and went down to 0, when we write the range, we list the 0 first since it's the least number, and we go to 40 psi, which was the greatest amount of pressure our tire had.